से शुरू जो बड़ा मेहरबान और नहायत रहम करने वाला है. The Petroleum Club of Pakistan is organizing a technical and focused webinar series, and today our session is on gas and oil pipeline management. The guest speaker for today is Alfred, and Alfred is basically an electrical engineer with project management professional and the senior pipeline integrity advisor, and currently he is a CEO at Pipecare Europe. The Alfred has about 35 years of overall business experience, in which 29 years in oil and gas, 23 years as PMP, and 21 years inline inspection and the integrity management, 19 years as a senior pipeline integrity advisor, and the last 14 years as a SCADA system and RTUS. And his areas of specializations are inline inspection, pipeline integrity management systems, supervisory control and data acquisition SCADA systems, and the remote terminal units RTUS. So I will request Alfred to please go ahead and introduce your company and start the session. Alfred, over to you.
Thank you very much, everybody, and a very good afternoon. And especially thanks to the Petroleum Club of Pakistan to enable us to have this presentation today. Can we go to the next slide, please? Yeah, Pipecare, the company I'm representing, is a global leader in providing complete pipeline solutions. And the major topic of today's presentation is advanced crack detection in oil and gas pipelines. Next slide, please. And before we begin with the webinar, I would like to take the advantage to have a brief safety moment, because safety is above all what we are doing in business and in private life. And because we have now experienced more than 1 year of this pandemic and it is still going on, we need to be reminded that we cannot let our guards down. Although people are getting tired of all these restrictions in traveling, in social meetings and everything, we cannot let our guards down. We need to wear our masks properly. We need to practice social distancing and follow the rules which have been set to protect us and others. That was the safety moment for today. And with the next slide, I give a brief introduction what we, Pipecare, are doing. The core of our business is inline inspection, where we are proud to offer all technologies from caliper to magnetic tools to ultrasonic tools, combo tools, and accessories. We are especially proud that all these tools have been developed by ourselves in-house and built in-house, also the related software. We have expanded our services from pure inline inspection and preparing the final report to provide also integrity services like further integrity assessments, like fitness for purpose, like special assessments, crack assessments, fatigue assessments, dent assessments, strain assessment. We have XYZ mapping with our inertial measuring units now as a commodity. And we have introduced the latest addition to our portfolio is the Predictor integrity software. And if we find the time, I will have a few words for that software later on. We have also, to help our customers for quick fixes, developed a pipeline repair method, which is based on a metal wrap carbon fiber repair. And we are a solution provider, meaning we are happy to accept challenges. We have helped our customers in the area of downhole, coiled and furnace tube inspection. We have built cyclone dust separations for pipelines which are heavily transporting dust, sand. We have big experience in flow line inspection, in unidirectional inspections, in loading lines, umbilical inspection, and magnetic surface inspection. The company is founded in 1998 in the UAE, has grown ever since, and is also known as Linscan, which was at that time an abbreviation for line scan, as for inline scan. But with the additional services that we have added to our portfolio and the experience we have gained in over 20 years, we decided it's time to show that we have moved forward, that we are no longer only an inline inspection company, but we provide solutions and we look at the pipeline as a whole. And this is why we are now using the name of Pipe Care, for we care for the pipelines. And this is not a takeover, this is not a sell or a merger. We have just gone through a rebranding and restructuring of the company. We are having right now approximately 410 employees worldwide, and we own more than 1,000 tools that we can use to inspect pipelines. The next slide, please. Our mission and vision are very, very clear. We want to provide best-in-class pipeline integrity services. As I said, not only inline inspection, but also the services which follow after, so that we do not let our customers alone with a final report. We help them further. We find innovative solutions for challenges which customers face us, and we want to be the preferred partner of our customers. And being a preferred partner means that we want to establish long-term relationships with customers and stakeholders, that we provide exceptional services, that we are operating safely and cause no harm to the environment. We are bringing innovation to the pipeline industry, and we use advanced technology. Next slide, please. Where we will see an overview of locations where we are already established and where we plan to grow further. So the black ones is our headquarters in Switzerland now. The blue ones are established entities. The gray ones are entities which are under creation. And I have marked Pakistan as we are considering to open also a branch in Pakistan. However, I have to say that this, of course, is depending on how the business is progressing. If we achieve a certain level of business in the country, then definitely we want to have a local branch. We want to have local workforce so that the money which is generated by these works stays in the country. Next slide, please. Potential and also maybe current customers in Pakistan. You may know all of these. I'm familiar with a few of them. I have in a previous company, I have worked with Parco already. And also here in Pipe Care, I was involved in inline inspections, which we did for Parco. Next slide, please. So the theme of this webinar, as I introduced it, is advanced crack detection in pipelines. And what I want to talk about is, first of all, we need to understand what is a crack, why pipelines crack, a few words about stress corrosion cracking. Then I will talk about methods for crack detection. I will sum up what I have presented, and when I'm available for an open discussion, answer your questions and go into more details where you think it is helpful. Next, please. This picture shows what we call the compass. It shows the detection capabilities, or the major detection capabilities of our tools. And what this compass shows, that there is no one tool which can find all features that you may face during the lifetime of a pipeline. And this is why we have specialized tools which are good at certain areas and are not good at other areas. What I said in the beginning, we are proud that we can offer all tool types. So doesn't matter which challenge you have, we can bring you the right tool. There's no need for compromise. We have the right tool at hand that you need to help you overcome your challenges. Next, please. So first of all, we need to talk about what is a crack. Next slide. And unfortunately, as we have only a PDF available, you see the full picture or the full slide, which would normally be showing up in steps. But independent of that, I'm using the definition from the Pipeline Operators Forum for crack and crack-like feature. A crack is a planar two-dimensional anomaly feature with a high length-to-width ratio, a sharp root radius, and a possible displacement surface opening smaller than 0.1 millimeter of the fracture surface. You see a drawing where a crack is indicated, and this may be even still closed, so no opening at all. What you also see is some lines, and these lines represent the magnetic lines of a magnetic tool which passes this crack. And what you see is that magnetic field just passes through that crack without being deflected. Whereas if we look at the crack-like feature, which has a similar definition, but the dimensions of the opening are different. The dimensions are between 0.1 and 1 millimeter opening of the fracture surface. And this is enough to deflect the magnetic field and give an indication to the sensor of a magnetic tool. What you also see, these pictures of real features which have been cut and examined in a lab. On the left picture, you see a metal loss feature on top and then a crack protruding into the pipe wall. The magnetic tool would see the metal loss feature, but not the crack. That's important to understand, that magnetic tools, independent of what other vendors may tell, they cannot see cracks. Cracks as per the definition of the Pipeline Operators Forum. And I have, in my own experience, I had one customer in Europe who tried to find stress corrosion cracking by a combination of the MFL and TFI tools. Unfortunately, 6 months after that inspection, he had a rupture in the pipeline, due to SCC, and this feature wasn't even in the data. So please, whenever it comes to crack detection, forget about magnetic tools being able to detect cracks reliably. This is a game of throwing the dice if you want to find cracks with magnetic tools. Next, please. Next picture, please. Yeah, what kind of cracks do we have? Cracks are not normally not in the pipeline right from the start. And we can have fatigue cracking, which is a little bit outstanding compared to all other crack types, because fatigue cracking is happening when the metal is repeatedly stressed. So it's very easy to explain this, what fatigue cracking is. If you have a paper clip and bend it several times, what you will see is that, or what you feel also is, when it gets hot, when it gets brittle, and after some time it breaks. And this is exactly what happens with fatigue cracking. So if you have a pipeline which has a very high pressure cycle, and very high means the number of cycles and also the differential pressure, then this pipeline may be threatened by fatigue cracking. Other crack types which happen many times is hydrogen-induced cracking, sulfide stress cracking, and stress corrosion cracking. Next slide, please. The risk with cracks and what makes them so dangerous is how they propagate. Because what is common to all cracks is, and also with corrosion features, is that they need to have a break in the protection. There needs to be a break in the pipeline insulation, in the coating. There needs to be a liquid together with that. There needs to be a certain temperature. And this may initiate a crack growth. Now, in the beginning, this crack behaves like a metal loss feature. It starts growing as a pit, but then, depending on the metal structure, it can start growing, and growing in length and depth. The big difference between cracks and metal loss features is that in a metal loss feature, you have a significant amount of metal loss. Whereas in a crack, the amount of metal loss is very, very small. And cracks grow over a certain period of time, and all of a sudden, they start an exponential growth, and this leads to unexpected and sudden failure. And this is what makes cracks so dangerous. It is very difficult to reliably detect the time in which the crack grows without threatening the integrity of the pipeline. And this is why it is important to detect cracks early and treat them, so that the exponential crack growth and the sudden failure will be avoided. To summarize, what needs to come together for cracking is, as I said, we need to have a breakdown in the surface film, meaning in the insulation. Or we need to have also the same, it can happen in the pipe, inside of the pipeline. We need to have a liquid which is corrosive. We need to have a certain composition of the medium which is transported in the pipeline. We need to have a certain temperature, certain pH value, and pressure cycling, and material composition. So all these factors come together and determine whether a pipeline is susceptible to cracks or not. What can be said as a general rule, that pipelines which are susceptible to cracking, they very often develop cracks within the first 15 to 20 kilometers after a compressor or a pumping station. But this is only one of the indications which may be used to determine whether a pipeline is susceptible to cracks or not. But it can be kept in mind as a rule of thumb, where to start looking if a pipeline is under threat of cracking. Next, please. A special type of cracking is stress corrosion cracking. And this was first recognized in 1965 in the US, and it was associated with high pH, meaning that there was high pH liquid, there was high temperature, and together with coating damage, which led to crack building and stress corrosion cracking. The most dangerous is not the single crack, the most dangerous is the stress cracking colony, that several cracks are building and all of a sudden they are growing together, and this contributes to that exponential growth of a crack. And if cracks merge, when suddenly the pipe wall is not that strong anymore and bursts. The other type, which was first identified in 1985 in Canada, is near neutral pH, SCC. Again, the parameters are the same. It's high temperature, it's pressure fluctuations, it's a lack in coating, and the result is the same, but small pits are building which grow to cracks, to crack colonies, and once this crack colony reaches a critical size, it very, very quickly bursts and creates a leak or a rupture. Next, please. So which options do we have to reliably detect cracks? There are two tools which can help us in that regard, which is the ultrasonic crack detection tool. And I made a screenshot here of what kind of features which tool is designed to find. Axial cracks, bends can be detected but not sized. SCC, circumferential cracks, hydrogen-induced cracking. These are the major features which this tool detects. I would like to add here that in the last 2 years, also the industry moved from not only detecting axial cracks, but also circumferential cracks. And our tool can do both with a very, very quick change of the sensor carrier in the field. So within 1 day, our tool can be reconfigured to run as a tool either in axial crack detection or circumferential crack detection. Next, please. Now we need to understand what is special about the crack detection tool. Why can't we use our standard ultrasonic wall thickness measurement tool? The explanation is that the UTWM tool sends the ultrasound perpendicular to the pipe wall. And as the cracks are also perpendicular to the pipe wall, the ultrasound will miss these cracks. So the data analyst will see nothing in the data. And in order to overcome that, a new tool was developed which uses sensors or transducers which are mounted at an angle of between 15 and 17 degrees. And this results that when the ultrasound hits the internal pipe wall, it is deflected so that it travels at a 45-degree angle and therefore will return to the transducer if it hits a crack, as you can see on the picture. And because the tool travels through the pipeline, there's only a limited amount of time that the tool, that the transducer is over a certain location. So what we see is that the tool records the first 3 echoes, which would give it the internal surface, the external surface, and the internal surface. So that internal cracks as well as external cracks can be detected. Next, please. What is important is that cracks need to be detected from both sides. This is why we have sensors mounted in 2 directions, so that cracks are seen from both sides. And we also have wall thickness measurement sensors on a crack detection tool, but not in an amount that we could do a full metal loss assessment of the results of the wall thickness measurement sensors. These are important to help the data analyst in detecting the size of a crack, meaning the length and the depth of a crack. The industry has moved from giving the depth of cracks in bands, which was in the past, where we had bands 0 to 1, 1 to 2, 2 to 4, or larger than 4 millimeters. We are now giving distinct sizes of the crack depth, which has an impact on the crack assessments, because when bands were given, always the worst case had to be taken. So even if a crack was 2.1 millimeter, for the assessment, because the bandwidth was from 2 to 4, the assessment always used the worst case, meaning 4 millimeters. And this resulted, of course, in much more repair recommendations, much earlier repair recommendations when was really necessary. And of course, it resulted also in higher expenditures. So now, with being able to give distinct depth sizes of cracks, the crack assessments are also much more accurate now. What you get from a crack assessment is the same type of report that you are used from a metal loss assessment. There's one difference, which is the sentence plot. What you are maybe familiar with from UTWM or also from MFL or TFI inspections is the sentence plot on the lower left with the typical ERF curve. ERF curve equals 1 means this is the repair line where features need to be taken care of. In crack detection, this ERF line has a different name. It's the anomaly assessment factor line. And it's, you see also that it has a different shape than the ERF line. But otherwise, the meanings of these lines, of these graphs are the same. Everything which is below the curve is safe. Everything which is outside of the curve, meaning up or on the right, needs to be taken care of. I would like to emphasize again here that we are always working with conservative approaches. So even if a feature reaches ERF1 or AAF1, this does not mean that this feature immediately fails. It is an indication that this feature needs to be taken care of. All codes and standards in the industry are conservative. We are also working with additional safety factors. So everything is done to prevent a rupture or a leak from happening. But once these limits are reached, then it is high time to take appropriate measures. Next. These are screenshots from real features, which we found with our crack detection tool. On the left, you see 2 cracks in longitudinal direction. And on the right, you see a crack field in axial direction. As I said, both types of cracks were found with the same tool. Just the orientation of the transducers had to be changed, but we can see the respective cracks. Next. Now we come to the EMATS tool, which is also a tool for crack detection, but a very special tool. The ultrasonic crack detection tool, as it uses ultrasound, needs a liquid couplant. And this causes a headache for all gas pipeline operators, because no gas pipeline operators wants to have a liquid in the pipeline, because this requires dewatering, drying, meaning additional expenditure. Of course, there is the option to run a batch with an ultrasonic crack detection tool, but still the pipeline needs to be cleaned up afterwards, needs to be dried before the normal operation can be restored. So this is why the EMATS tool was developed, where EMAT stands for electromagnetic acoustic transducer. You see the capabilities of the tool. It is similar to the ultrasonic crack detection tool. It has one more capability, and this is the detection of coating disbondment. And I will come back to that a little bit later. Next slide, please. This is how the EMAT tool looks. And for those of you who are familiar with inline inspection tools, it resembles a little bit an MFL tool, a tool which is used for metal loss inspection, and rightly so. Because also on the EMATS tool, magnetic fields are used, and electromagnetic fields are used. Next slide, please. The principle, or the 2 principles, are shown on this slide. On the left, the traditional ultrasonic inspection tool, where the ultrasound is created in a piezoelectric crystal, and is wandering through the liquid couplant to the pipe wall, and when does it work in the pipe wall. As we said, in gas pipelines, we do not want to have a liquid couplant, so the EMATS tool has to create the ultrasound inside the pipe wall. And this is done with the use of magnetic and electromagnetic fields. Next slide, please. So what's happening is that one of two methods can be used. One is using Lorentz force, one is using magnetostriction. The result of both methods is the same, that the metal grid is oscillating and creating an ultrasound or even different types of ultrasound inside the pipe wall. The difference between the Lorentz force and the magnetostriction is that magnetostriction has certain advantages, as it creates a static magnetic field and an oscillating electromagnetic field. This has benefits when it comes to better signal-to-noise ratio of the reflected signals. The Lorentz force method requires that the sensor is much closer to the pipe wall, maximum 2 millimeters, to work effectively, whereas the magnetostriction method works also very well at a distance of 4 millimeters. You understand that these are very, very small distances to the pipe wall, and this was one of the reasons why it took a long time to develop EMAT tools which can inspect long distances of pipe, let's say 7 to 100 kilometers. The reason is that the transducers need to be protected from damage, and to find the right material was a big challenge. To have a material which is strong enough to withstand all the hits of the girth welds along the pipeline, and maybe even a rough inner surface, but also smooth enough that the distance to the pipe wall is kept, so that the transducers can get a good signal back from any limitations or any anomalies in the pipe wall. Next. These are some screenshots of findings with an EMATS tool. You can see on the left a crack field in longitudinal direction, a crack, and also a crack field in longitudinal direction on the upper right, and a gouge. On the lower right, this is a combination of different features. One is a band, and the other feature is a coating disbondment. Next slide, please. And the coating disbondment is determined by checking the amplitude excuse me, of the reflected signals. Because when the coating is disbonded, the reflected signal is stronger, approximately 2 dB stronger than a signal which is reflected from a pipe wall which has a coating. Now, of course, there is a certain area required to be certain that there is a coating disbondment, and this area is approximately 6 by 6 centimeters. Only if there is a a total disbondment of that area when we can be sure that there is really a coating disbondment. Okay, next. Summary and conclusions. We have efficient crack detection methods available. For best in liquids is the ultrasonic crack detection tool. For gas pipelines, definitely the EMATS tool. The EMATS tool can also work in liquid lines. However, I would always prefer the ultrasonic crack detection tool because it's easier to handle, it's lighter than the EMAT tool, and it's much easier to clean. The results of both tools are on the same level. This was one of the requirements when the EMAT tool was developed. It should be on the same confidence level than the ultrasonic crack detection tool. And both methods give reliable information on cracks in pipeline, especially on stress corrosion cracking. One recommendation when you are planning to do a crack detection inspection, always make sure that you have a metal loss inspection done either at the same time or not longer than 1 year behind. And this is for a reason. Metal loss features, general corrosion is a random process, and these features may develop sharp edges. And the sharp edge may be interpreted by the ultrasonic crack detection tool and therefore the analyst as a crack or a crack-like feature. And in order to avoid false positives means that we declare that a feature is a crack, and the customer goes out into the field, digs up this location, and finds that it is a metal loss feature instead of a crack. This is a false positive, and this is what we want to avoid. And in order to help the data analysts, a metal loss inspection will help tremendously. Again, from my experience, this happened with a customer in South America, where we were doing a crack inspection only because the customer wanted to save some money. We had discussions for about 4 months about the accuracy of our reports and the calls that we made, because the customer said they found only 50% of the features as being cracks. So I flew over to South America, had a meeting with the customer. We looked into the data, and we quickly came to that conclusion that a metal loss inspection is required. And then the customer said, "Oh, but we have one." And I said, "Okay, bring in the data." We looked in the data, we looked at these features where they didn't find what we told them. And when it was obvious that exactly it had happened as I explained, these were metal loss features with a sharp edge, and this was interpreted as a crack. And when we did, again, the obvious, we reanalyzed the crack detection data. We compared with the inspection of the metal loss features, and afterwards, the hit rate was 95%. So therefore, the recommendation that every crack detection inspection is accompanied with a metal loss inspection. Next. In summary, we are here to help you with your challenges. And don't think that the challenges is too big for us. There are no unpickable pipelines anymore. Every pipeline is pickable. They may be difficult to inspect, but if it is required, there is a solution for that. So we do not need to have any pipelines uninspected anymore. And we are providing solutions, and we are not leaving you alone after an inspection. We help you further to interpret the inspection results, to look at what can be done to keep your pipeline safe, and most important, keep the product in the pipe. With this, I want to finish my presentation, and I'm ready now for your questions.
Okay, Zahid has raised the hand. Zahid, please introduce yourself and then ask the question.
Yeah, I'd just like to know quick inspection. I just want to know, do you have any method for CRA pipeline, like pipe which is cladded, double lined pipe, which you use for
Cladded pipe is a challenge, definitely, but it can be inspected with ultrasound tools.
Pardon?
Yeah. With ultrasonic tools, you can inspect cladded pipe. There's no problem there.
What is the complete method? Can you tell me the complete method, or you can send me an email through your presentation or something, some material so we can study, because we are facing serious problem in assessment of the pipeline,
Yeah, okay. Definitely, we can do this. Please leave your email and your question with the organizers, and they will forward to me, and I will be happy to reply.
Because we are dealing with the highest CO2, in gas. So we are using cladded pipe instead of duplex. So this is a way we have to inspect these pipelines before using any further.
Yeah.
So just to make a benchmark,
Yes.
So you understand what I want to say?
Yes, I understand. Just as a coincidence, I had a discussion with a customer in the Caspian Sea just on Monday this week about the same topic.
Mm-hmm.
So there are solutions how to inspect cladded pipes. Yes.
Yeah. Just to check the reliability of the pipe, So
yes.
Instead of using any further.
Yes.
Okay, I'm dropping my email, and you can send me, any material, whatever is possible to do inline inspection for these sort of pipes.
Yes. Yep. Definitely.
Okay. Thank you.
Okay, for the next one, Faisal, please, you can ask.
Yes, Alfred, I would like to ask in continuation of Mr. Zahid Mahmood, as he asked or inquired about the cladded CRA pipelines. In your presentation, you have demonstrated two techniques. One is the UTCD and other one is EMAT.
Yes.
Can either of these two techniques be used for cladded CRA pipelines for crack detection?
Yes, the UTCD.
Yeah. We can use UTCD for the cladded CRA pipelines.
Yes.
And the phenomena will be the same as you have demonstrated in this presentation.
Okay, what we need to do is I always need to ask one question when it comes to cladded pipelines.
Sure.
Are the two layers metallurgically bonded or not? Yeah, in the past, there have been pipelines been built where the inner layer was just pushed into the outer layer, and there was no bond between the two layers. If this is the case, then we have, of course, a problem. If there is a bond between the two layers, then it's no problem.
Yeah, I understand. There are two type of pipes we are using. One is cladded pipe, and other one is the lined pipe. Because in a long run, like we are only using this overlay pipe for fabrication jobs. We're using a
Mhm.
cladded pipe, but it's welded with the outer pipe. So it is basically this is called overlay pipe. We are using that for
Yeah.
only for fabrication purpose, but for cross country pipeline, we are using that line pipe you're talking about.
Yeah. So,
Basically, we have to respect this line pipe. They are not
Okay,
physically bonded with each other.
Alfred, I want to say something here.
yeah, please.
Okay, this is Atif Kamar. I'm a territory manager, Far East, taking care of Pakistan also from Pipe Care. Regarding the what Alfred mentioned about the problem, so the best idea is if you guys can arrange the sample of the pipe, like 6 meter or 8 meter. If you do not have this information about like how it is bonded between that, so we can also have bring it here and the test the tools and the verifications and everything. Because we had done in I think ADNOC project where we they bring their pipe and we test that and we verify the results and everything. So this is also an opportunity before going to the actual job. We can combine and work together. Like if you can have some pieces of pipe around 6 to 9 meter, okay, and you can ship back to us by sea or something. So we can also have the pull through test and we can invite you also to witness it.
Yeah, that is also a good idea. We can use
Hello?
that. If we have got spare pipes, we can use that and put some detects
Yeah.
parts in that, and then we can detect with use any type of tool. Maybe EMAT
Yes,
inspection or
well,
something.
yeah, because it's for example, once we can make the defects inside. Once you bring us the pipe, we will make the artificial defect, and we can
Mhm.
test in front of you, and we can show you the data and whatever the tolerance. Sometimes, like maybe you tolerance you agree with. Okay, we are okay with this tolerance for our pipeline, and we can go ahead. So, and also this is our we have a base in UAE, so by sea it can easily come very cheap.
Uh, but Atif, what I feel, if there is any buckling or something, if you put that line, the pig, they maybe damage the tools, because actually what is happening inside we don't know.
No, because we have, like we obviously we will not put the tool first, this heavy tool or expensive tool. We have a process like we, for example, we will start with the foam peg, we start with the gauge peg. So this is called proving of the pipeline to be piggable. So, if you because this is very cheap also, it's not that about like for example for your pipeline, first you need to find out okay is it piggable or not. So that also scenarios we do not have the launcher receiver, we can also help it on this one also. So these things can be done very easily because we have to do the project in pieces. So it will not be we do not go to the invest on the premium tool. First, we for example on the first phase we made and work on the feasibility of the pipeline. The second phase we work on the what is called intelligent pigging pull through test in our base. So these are very manageable expenses, and also it will what is called satisfy you before going to the big job.
But we are handling only very thick, the thickness of the cladded pipe is very less. It is around 3 mm. So do you think we use any tool like that to affect the cladding?
The whole pipe wall thickness or the only the cladded portion.
Because the cladded is inside, na, we have to check the cladded pipe basically. It is the one which is protecting from corrosion.
No, no. I understand the total wall thickness is supposed to be the wall thickness of the pipe and cladded area.
Yeah, that's right.
So yeah. So what is the total wall thickness of the pipe?
Wall thickness is you can say the back pipe is zero point 0.5 inch and
Yeah.
X80 grade
Yeah,
and
that is fine because we had done this kind of pipe before also, where 3 millimeter is the and plus, so there is no issue of the buckling and everything. I'm telling you. So, but for regarding the result and accuracy of the defect and reporting, we always prefer to have the piece of pipe in our yard, so everybody will satisfy before
that is
going.
fine because
Because
And but that you can do it on location also, or you need to have that pipe in your location.
okay, for the location, you understand, like for the location, it may be more expensive to you. Why? Because uh, as a territory manager, I can support you if you bring the pipe. We can do the free testing or something like that. I can support on that and satisfy you. But when I have to bring the tool to you, it will be a commercial thing. And for example, if the result is not in your favor, but for me, shipping the pipe to us is no problem. So the main thing for us is like we bringing the tool to you and doing the things, and then it will cost both of us. And
Where do you have a facility? Mr.
Sharjah, UAE.
Okay.
We have a full-fledged facility, and the people are coming over. For example, Parco also visited. I think PPL also before, maybe in 2012 or 11 visited. OGDCL visited us. Shell visited us. Pakistan. This is I'm talking about only Pakistan clients.
Okay.
And we had already successful Parco verification, OGDCL, Shell. So you can we have a proven record. And also for CRA.
Can we have a separate meeting with
Okay,
on
no
this?
issue.
Yeah, I think it's better.
I already dropped an email.
Faisal, you are from the PPL, so it's better drop an email or you have a separate meeting for that. It will be better. Okay. So Shoaib, do you have any questions or you want to say something?
I have one more
yes,
question. Can I please?
yes. First of all, thank you, Alfred. Thank you for taking time out for us, and it's an excellent presentation. My one question is regarding the propagation of the crack. Like, if we identify the crack, and so is there any mechanism that after we identify the crack in the pipeline, either from inside or outside, can we also predict the propagation direction of the crack at the same time, or that will be still a question mark?
Cracks, no. And the crack propagation is either in axial or in circumferential direction. So if a small crack is detected to grow to be axial oriented, it will grow in axial direction. And if it is detected as a circumferential crack, it will continue to grow in circumferential direction. They do not change direction. They grow in depth and they grow in the original direction that they started. Also, maybe interesting to know is that in the pipe body, the cracks to 99% they grow in axial direction, because this is a result of a stress. And where we have cracks in circumferential direction, this may be in Gulf wells and close to Gulf wells, in the heat effect zone of the Gulf wells.
Yes, anyone else has any question? Faisal, you want to ask again?
Yes, in fact, I want to talk a little bit about coating disbondment. Alfred has shared us that EMAT may also determine or identify coating disbondment. So my question is this an advanced technique to identify coating disbondment? Is there any other technique which can also identify coating disbondment like EMAT?
No, this is a capability unique to the EMAT tool.
Right.
As I said, what is used is differences in the amplitude of the reflected signal.
Okay.
Yeah, and neither the ultrasonic wall measurement tool nor the tools have this kind of recordings or this capability. Yeah, in the UTWM we do not measure amplitudes; we measure times of flight when signals are returning to the transducer. And with the magnetic tool, this is not possible at all, because we are just measuring a magnetic field. So there have been in the past, there have been trials to see whether a magnetic tool may detect coating disbondment, but this was not successful. So the only method right now is the EMATS tool.
Okay. And is it also help us to identify coating damages?
Well, as I said, the area that needs to be disbonded is a 6 by 6 centimeter square.
Yeah.
Yeah, and this tells us that there is no coating at the pipe wall, on the pipe wall. This
Okay.
it may just be disbonded. It may be fully gone away. This is something that we cannot tell. This you can only see when you go into the field. And
through direct examination.
And damage, if the damage is larger than 6 by 6 and it is fully disbonded, yes, we can see it.
Okay.
But we cannot tell you what kind of damage has happened to the coating. We can only tell you that, okay, here in that location there is no coating. But why?
Okay.
That's not possible to tell.
Okay. In fact, there is another technique known as DCVG, direct current voltage gradient, which is an indirect inspection tool to identify coating damages. I hope you have you are well aware of it.
Yeah, but this is not inline sound survey.
Exactly.
Where you need to walk along the pipeline. Of course, I'm aware of it.
Good.
Okay, Faisal, if you have any further queries, you can just send an email to Atif or Alfred, or just drop an email here. We can pass it to Alfred. So anyone else has any questions? Shoaib?
No, thank you. Thank you for answering my question already. Thank you.
Okay, then we can just close the session. Alfred, thanks again. It was really a very informative session, and you have explained it very well. And thanks for Shoaib as well for coordinating for this session. And I hope we can have more sessions in the near future. So thanks again, everyone, and a special thanks. And till now, okay, Allah Hafiz.
Thank you very much, everybody, for your participation and your questions. I will be happy to come back and talk to you about other items in relation to pipeline integrity. Thank you very much.
Okay. Bye-bye.